I stopped the last video short just a split second too soon. Let's talk about f of x equals 3 to the negative x minus 1. So first I'm going to take this 3 to the negative x minus 1, and I'm going to ask, what does this negative on the inside of the exponential function do to our graph of 3 to the x? Okay, what does it do to that graph? Well, it's going to reflect it. Let me write this in orange. That negative reflects over the y-axis. Over the y-axis. This subtract 1 right here, this subtract 1, is a translation down 1 unit. So we're going to take our graph of 3 to the x. That would be this graph right here. So I'm going to do this right there because I don't really want to make the whole graph, but it's that graph right there that I've put dashed. We're going to take this and we're going to reflect over the y-axis. So we reflect over y, and we get that point. Reflect over a y, reflect over a y, reflect over a y. Then we're going to take each one of those points and we're going to translate down, translate down, translate down, translate down. Now before I draw the curve, my asymptote that is normally going towards negative infinity on the x-axis reflected over the y-axis and is going towards positive infinity. Likewise, the translate down has brought that asymptote down to y equals negative 1. So now when I connect these purple points of my graph, I get my graph that looks exactly like that. And don't forget that it's going to continue and it's going to hug that horizontal asymptote. So let's talk about the limit as x approaches infinity of our function 3 to the negative x minus 1. Let's rewrite this limit using some laws that we have. The limit as x approaches infinity of 3 to the negative x plus the limit as x approaches infinity of negative 1. I could also make this minus, so I can make this right here be a minus, and then I can make this be positive 1. So I can do that, and I'm going to do that. Because sometimes it's easier to see what's happening with a positive, a little bit easier than when we're looking at what's happening to a negative. So what's happening right here? Well, this is the limit as x approaches infinity of 1/3 raised to the x power, which is the same thing as the limit as x approaches infinity of 1/3 to the x. Now, as x gets really, really, really large, what's going to happen to this denominator? Well, as x gets really, really large, as x approaches infinity, that means as x gets really, really large, 1 over a humongous number is going to equal 0. So this value, this limit right here, is going to be 0. I'm going to take this, I'm going to kind of move it out of the way. Let's resize it. There we go. So this value right here becomes 0. And then I've got that minus, don't forget minus, Maybe I'll change that color since I used red again. Let's change that color to, let's just make it black like the rest of it. Okay, now I'm going to say, let me use this pretty color, pink. The limit as x approaches infinity of 1. And what is the limit as x approaches infinity of a constant? Well, it is the constant, so it's 1. 0 minus 1 is equal to -1. So the limit as x approaches infinity of this function is equal to -1. That's the horizontal asymptote. And look here, we had that horizontal asymptote right here, y equals -1. Hot dog. So, long story short, the limit as x approaches infinity of f of x is equal to the horizontal asymptote, which is equal to y equals -1.